Today, I'm going to summarize the Chapter 1 and Chapter 2 in Spatial Database. What are the useful areas of the Spatial Database? The doctor can use MRI to find a similar pattern between patients, and the supply manager can determine which are the best place to build distribution warehouse and retail store, and farmer can estimate the minimum amount of the pesticide on their farm. GSI and SDBMS. GSI stands for Geographic Information System, which provide rich analysis operations such as finding connectivity, shortest paths, searching nearest neighbors, and so on. However, it's bad for GSI to solve the questions like find all the countries which are completely surrounded by another country. So here comes the Spatial Database Manager system. The Spatial Database is good for handling a large amount of data and provide set-based query. Since the Spatial Database is based on traditional database, it also guaranteed concurrency control and data consistency. Now we'll talk about the architecture of Spatial Database Manager system. We can build a spatial database based on object relational database. In this picture from the left to right, we can see the spatial database application. Spatial application, and the application layer didn't directly interact with object relational database, and the median layer here contains a spatial data model, abstract data type, and query language, spatial indexing, and some efficient algorithm for query optimization. In order to do a range query in Spatial SQL, we need first to minimize our search space. So we need to do some filtering. For each dataset, we will first find the minimum rectangle of each dataset. Then we can apply swipe line algorithm from the left to right, and during insertion of the intervals, we can do range query inside the interval search tree in order to remove redundant dataset. And in the end, we will have fewer dataset to deal with. So it means our SQL range query will go faster. And in Chapter 2, there are two common models for spatial data. The first one is called field-based model, which use function with domains and range to represent data. The other one is object model, which use some collection data type to store data. And the field models are usually used for modeling continuous spatial data, such as elevations and temperatures. And object models are usually used for modeling transportation networks. So for field-based model, we care about how datasets interact with each other. So there are three operations. The first one is local operations. such as union, plus, and other basic mathematical operations. The second one is focal operation, which represent a gradient of elevation function. The third one is called zonal operation, which represent integration function in calculus. So, for example, the calculating the average height of the tree for each species is zonal operation. For spatial data, for spatial object model, we also care about how the dataset interact with each other. So there's four operations here. The first one is topological operation, such as if a point is inside or outside a region, or these two regions are connected or overlapped. For non-topological operations, this kind of operation will be counting the distance between 2 points, or counting the area of the region. The third one is called directional operations, which can clarify the absolute or relative position of each dataset. Finally, we have some dynamic spatial operation, which will update the value in our database, such as generating, merging, translating, rotating, scaling, and refactoring. In the book, it mentioned 3 steps to design a database. The first is to convert all the related information into higher level conceptual data module. And the ER model is one of the popular conceptual design tools. The second step is called logical model phase, which implement the concept in the ER model into a real commercial database. The final step is to deal with our real computer systems, including memory management, database indexing, networking, and so on. Finally, I want to talk about UML, the most popular object-oriented design tool for most object-oriented programming language. The difference between the ER model and the UML is that UML provides methods which are the logical computation with some attributes or value passed by. Also, UML does not support weak entity. So it means that all objects in UML have unique ID. So that's all for today. Thank you so much.